Hello again, algebra students. Today we're just going to review the exponent rules that we learned in the last lesson. And I want you to remember that when we see something that looks like this, we call it a power. That just means that it's something with an exponent. So the base is the x, that's the thing that's getting used as a factor and it's being multiplied by itself several times. And the exponent is 3, which means I'm going to use that x 3 times. So if I'd write that out, that'd be x times x times x. The product of powers property. Now, if you remember, we said product means multiply. Powers are things with exponents. So we're just multiplying things that have exponents. So if we have the same bases, like we do right here, 4 to the 6th and 4 to the 3rd, I would add those exponents to get 4 to the 9th. And I can do the same thing with variables. So if I had a to the m and a to the n, I would add those exponents and I would get a to the m plus n. Now, I have a couple of examples like that. Remember, if there's no number in front of a variable, you know that there's really a 1 there as a coefficient. So if I would multiply the 1 times the 6, I would get a 6. And for my m's, I have m to the 3rd and m to the 5th. When I have those, again, we add those exponents, so that'll be m to the 8th. Here I have 2x squared times x to the 4th, and once again, we can sneak a 1 right there. 2 times 1 would be 2. X squared times x to the 4th would be x to the 6th power. And for this last example, multiplying the coefficients, so this time it's not just a 1, we've got a 3 times a 3 would give us a 9, and then an n and an n squared, and just like when there's no coefficient, you know there's a 1. When there's no exponent showing, you also know that's a 1. So I would have n to the 1st and n to the 2nd would give me n to the 3rd power. The other two rules that we learned yesterday was when we have a power of a power, so an exponent on something that already has an exponent, and in that case we would take the 6 and the 3, for instance, and we would multiply those to get 4 to the 18th power. Or if we have just variables, a to the m to the nth power, we would multiply those two, and that's what gives us m times n as our exponent. And the third one was, well, if I can scroll here, the power of a product, which means that I have an exponent on something that had been multiplied together. So if we just had numbers, for instance, 3 times 2 in parentheses to the 5th power, that exponent, remember, it's not really a distribution, but it just kind of goes on to each of the factors, each of the things that are getting multiplied. So I would get 3 to the 5th power and 2 to the 5th power. Or in algebra, this m exponent would go onto the a and onto the b. So we're going to kind of mix all of those rules together now. It's not just going to be one rule at a time. I would take a problem like this, and you could distribute or use that 3 for an exponent on the outside to everything. Personally, I like to kind of clean this up. I don't know why I've got 2 different a's in here. I'm sorry about that. But just simplifying what's inside the parentheses. Remember, this is really a to the 1st power right here. Inside the parentheses, I have a 2 times that 1 is just a 2. A to the 4th and a to the 1st gives me a to the 5th power. And this is all being cubed. So that exponent would go onto the 2. And the a, remember, we're going to multiply those. Just for this one time, I'm going to write it out as 5 times 3 to remind you. But 2 to the 3rd power, remember, that's not 6. That's really 8. 2 times 2 is 4, times 2 is 8. A to the 15th power. In this problem, again, I like to just kind of clean up what's inside the parentheses. So I would have 4 times 2 would be an 8. And then I've got an x squared and an x to the 6th would be an x to the 8th. And I have this problem in particular because I want to make sure that you see the difference between what happens here. When this exponent goes on the 8, I'll get 8 squared. And when it goes on the x, I'll have 8 times 2. Oh, that's a really horrible x, I'm sorry. So I'm going to get 8 squared is going to be 64, not 16, but the x will have an exponent of 16 because we just multiply those. Here, when I combine things and simplify inside the parentheses, 5 times 6 would be 30, n to the 10th, n to the 12th, that's going to be n to the 22nd power. Just adding those exponents, and then the entire thing is going to be squared. So 30 squared, you could write out 30 squared if you wanted to first, but you could also just figure that out, and that's going to be 900. And the n, we're going to multiply those exponents, so 22 times 2 is going to be 44. And one more problem. Sometimes we'll have a fraction as the coefficient. So this one I'm going to write out again just like this so that we can discuss it. But that exponent of 3 goes on the entire fraction, not just the numerator, it's the whole fraction. This a is going to be to the 12th power when we multiply those exponents, and the b will be to the 15th power. Now, 2/3 cubed, 2/3 times 2/3 times 2/3. You can certainly write that out if you want to, but I know that in the numerator I would have 2 to the 3rd power, which is 8, and in the denominator I'll have 3 to the 3rd power, which is 27. Here, I have to, just like all the other times we work with order of operations, I have to get rid of my parentheses. So I would need to take care of this part first. So that k to the 4th is just going to hang out for a second, and I'll get k to the power to a power. We're going to multiply 8th power. And then because those are the same bases, I'll have k to the 12th power. Same base as we add the exponents. This one looks kind of weird because we've got parentheses inside parentheses, and that doesn't happen real often today, but I do want you to see it once. Just simplifying inside again, let's just take care of this part. 2 to the 3rd power is going to be 8, and that's x to the 3rd. And I have an x squared, and this is all to the 3rd power. So I would have 8 to the 3rd power and x to the 5th power, just simplifying inside there. Then 8 to the 3rd power, I believe, is 512. And we would have, oh, hold on. I made a mistake here. Hold on. Let me backtrack just a bit. I shouldn't have had that 3 there yet. I was just simplifying inside the parentheses. I'm very sorry. That would just be an 8, x to the 5th, and then that's all to the 3rd power. So now I would get 8 to the 3rd power is going to be 512. And x to the 15th power. On this problem, distributing this 2, I know that this isn't alphabetical, which isn't typical for us, but we'll start with it just the way it is. So I'll have a y squared and an x to the 6th power. We multiply those exponents, and then it's still times a 3xy. So I'd put my coefficient first. Then for my x's, I have an x to the 6th and I have an x to the 1st, which is going to give me x to the 7th. And I have a y to the 2nd and a y to the 1st, which would be y to the 3rd. And on this example, just starting to get more stuff going on, but none of it is any more difficult than what we've already done. So I'm just going to write this one underneath here. This isn't going to change yet. 2b to the 4th times 2a squared b squared when I distribute this. 2 squared is going to be 4. A squared, b to the 8th power. Then I'm going to multiply all of the coefficients. So 2 times 2 is 4, times 4 is going to be 16. For my a's, I've got an a squared and an a squared gives me a to the 4th. And for my b's, I've got a b to the 4th and a b to the 2nd. So far that's b to the 6th. Then I've got a b to the 8th. So b to the 6th and b to the 8th would be b to the 14th. Then, last slide here. Finding the area of a square. Remember, if it's a square, that means that the side lengths all match. So that means that the length and the width, or the base and the height, are both that 5x squared y to the 4th. The area of a square is going to be that side length squared. So this is going to be 5 squared is going to be 25 x to the 4th y to the 8th. This didn't give us any units, so whatever those units would happen to be, feet or inches or centimeters or miles or whatever, this is going to be square units. And for this last problem, finding the volume of a cube. Now the volume of a cube is going to be the side length cubed. Instead of squared like it is for area, it's cubed for volume. So we're going to have the same numbers. I chose the same side length, but this is going to be to the 3rd power. So 5 to the 3rd power. 5 times 5 is 25, times 5 is 125. X to the, multiplying that, we'll get x to the 6th, and y to the 12th. Again, because it's volume, the units that we get here are going to be cubic. So today you have a worksheet to do. It looks very similar to yesterday's worksheet, but we've got more story problems and some other volume and area kind of problems. But if you need any help with any of the problems on the worksheet, make sure you ask.